Hello learners, welcome to Fike Maths with theorem. And today we are going to be looking at circle geometry under mathematics. And our quote for today will be: the more problems you solve, the more solutions you have. Like I always tell my students, try as much as possible to solve more problems. As you solve more problems, you will have more solutions. And guess what? Those that will eventually encounter any of such problems will come to you for solution. So the more problems you solve, the more solutions you have. Alright? So having said that, let's dive into what we have today. Okay, so look at this. This is circle geometry. Now, if you see a kind of question like this, how do you solve it? This line is drawn from here to here, this line 80, is called target. And the question is, you have to solve y. You have to solve y. And y is b, this angle. You have to solve y, alright? So how do you solve y? The first thing you are supposed to do here is to identify the angle that is at the target to the circle, which is this angle, 75 degrees. And the theorem that backs this up, right, is angle between target to the circle and a chord drawn from its point. This is the point of the target. This is the target to the circle, that is a line that touches the external part of the circle from outside. Okay, so and the chord drawn from its point of contact. This is the chord. Remember, a chord is a line that divides circle into two, but not into two equal halves, unlike diameter. So this is a chord. You can say DT is a chord, or TD, as the case may be, and BT or TB is a chord. Alright? So this angle is equal to the alternate segment. The alternate segment is not fully revealed, and the angle of the alternate segment is not fully revealed, and that is why we just need to join B to D. So we are going to extend B to D like that, so that this angle, addition of 12 degrees and another angle here, will give us what we require, right? So let's say this angle is, let's call it another letter. Let's say this angle is C. Okay? Let's call this C. So if this is C, now if this is C, alright, so we can easily refer to DBC, that is this angle, DBC. We can easily say that 75 degrees is equals to 12 degrees plus DBC, angle DBC, meaning that you can see that the curve here is on B, meaning that you are focusing on the angle that it forms at B. Alright? So, and what does which theorem backs this up? Because whenever you write every part, you must tell us the theorem that backs it up. So you can easily shorten it as alternate segments. Alright, so this means that DBC, this implies that DBC will be 75 degrees minus 12 degrees, which equals 75 minus 12 degrees. That should give us 5 minus 2, that's 3, 7 minus 1, that's 6. Am I right? Yes, 63 degrees. So DBC equals 63 degrees. So remember, what we want to find is angle y, that is the obtuse angle y. Okay, because BCD, there are two angles here. We have BCD of obtuse angle BCD which is y, and we have reflex angle BCD, which is this, the external part, the remaining angle that makes it angle at a point, right? So now, how do we find now DBC is 63 degrees, right? So we can also say that BDC, that is this angle. So we can also say that BDC is also 63 degrees. Why? That's base angle of an isosceles. Because if you look at this triangle BCD, you will discover that this is an isosceles triangle. So which means BDC equals 63 degrees. What is the reason? Base angle. This is the short form. Base angles of isosceles triangle. Alright? So base angle of isosceles triangle. Now let me state this. Whenever you are solving question on geometry, whether circle geometry or any other geometry, it must, the theorem that backs your facts, your solution, the theorem that backs it up must be well stated. Otherwise, you will not get the mark for what you are doing. Alright? So you have that. Now that we know our base angle, then to find angle y is easier. All we need to do is y equals 180. We subtract the addition of this angle from 180. 63 plus 63. Alright? And what is the reason for that? Sum of angles in a triangle. Alright? Sum of angles in a triangle. Sum of angles in a triangle. So y equals 180 minus, this is 63 plus 63, which is 126. 180, like this one. 180 minus 26 minus 126, that should give us 54 degrees. Alright? 54 degrees. That's the angle y we're expected to find. Now, so suppose another question states that you should find angle BTD. Then that's another theorem. And I think there's something wrong here. This is supposed to extend to the center. Okay, so this is our okay. Alright, so the angle is supposed to extend to center. That's what I just meant. But it doesn't affect the previous solution that we've done. Alright, so suppose another question asks you to find angle BTD. So what you're supposed to use, that's another theorem that states that angle sustained by an arc of a circle at center, because this has formed an arc. BCD is now an arc. Okay, angle sustained by an arc of a circle at center is twice the one at circumference. Right? Twice the one at circumference. That is this angle BTD. Angle sustained by this arc. Okay, this is an arc. And this arc BCD. This is an arc like this. Like this. Like this. So that's the arc of the circle. So angle sustained by an arc of the circle at center is twice the one at circumference. That is the angle formed at circumference, which is BCD. This angle. So you already know what that will give you like that. So that is how to attempt or how to solve questions like this in circle geometry. Alright? So see you next time on Figure Maths with Theorem. Bye.